Okay, so filling in my table here, 2 to the 4th power, that'd be 2 times 2 times 2 times 2, that's 16. Moving down to 2 to the 3rd, that would just be 3 2s, so that's 8. 2 squared is 4, 2 to the 1st power is 2. And I asked you when you hit that solid black bar to talk about the pattern that was happening. What is the pattern that's happening here, Joe? Okay.
Like the top one?
Yeah, yes.
Divided by the number by the base.
Divided by the base, yes. Okay, so we're kind of dividing by 2 each time, right? Which would make sense because 2 to the 4th would be 4 2's multiplied out. 2 to the 3rd would only be 3 2's multiplied out. So I have to divide out one of those 2's each time, right? So if I continue following this pattern, what should 2 to the 0 be? You take out the last 2 that you had, and you're left with just 1, right? Not 0, I'm left with 1. Remember when we're talking dividing, if I divide out the last 2 that I had, I don't have any 2's left. I'm just left with an answer of 1. Okay, now we got to stretch ourselves a little bit. Now where would I go after that for 2 to the negative 1 power? What? 0.5? Okay, let's talk fractions, just because that's what I want to do. 1/2, right? And I'm even going to write it a little stranger, if that's even a word. 1 over 2 to the 1st power. Okay, and then if I do that again, what do I get? 1/4. Which I will write strangely again, which is the same as 1 over 2 squared. Okay, now I want to do one more thing to kind of try to drive this point home. I'm not going to talk about the specific rule yet, but I'm going to do one more thing to kind of drive this rule home. You don't necessarily have to write this down, but I just want to show you this, okay? So look up at my screen really quick. All right, so I've given you this problem in the past or something similar to it. If I have that, what would be my answer for that problem? What'd you say, Jada? 3 exponent 2 where? On the bottom, right? My bigger exponents is on bottom, so I would subtract my exponents and I would have 3 squared on bottom. Right? That's how I've always taught you to do it in the past. Let me just show you, and please don't start doing this, but I just want to show it to you. I always said before we wanted to avoid negative exponents, okay? But you could potentially do this. I don't want you to, but you could potentially do this and do top minus bottom. So if I did top minus bottom and did 4 minus 6, what would my exponent be? Negative 2. And that would then go on top because I started on top. So I just did the same problem twice and got 2 different answers. That must mean that these 2 answers are the same. So that means 3 to the negative 2 power is the same as 1 over 3 to the 2 power. So I want you to just kind of talk about that for about 30 seconds here with your groups. See if you guys can come up with a rule for what we are supposed to do with negative exponents. Go ahead. Okay, so this would be the second blank down. We'll come back up to the 0 exponent. This would be the second blank down. Any number except 0 with a negative exponent equals its what with a positive exponent? Well, actually, we don't necessarily have to fit it into this box yet. What did you guys come up with when you talked about what the rule for a negative exponent would be? What did you say? Because I heard good things. Yep.
You put the negative on the bottom when you multiply.
Okay, so I would just take that exponent that has the negative power and put it on the bottom. Okay? Anything else? Anybody have anything different than that? Is that the gist of the conversation? So all of the ones that we've dealt with so far started on top and flipped down to the bottom, like Isabel said. So what do we call that when we take a piece and flip it? Yeah, it's a reciprocal. Okay. So any number except 0 with a negative exponent equals its reciprocal. With a positive exponent. And that's important. When you flip spots for that negative exponent, when you flip the spot, it has to turn positive. Okay? So 6 to the negative 4. Where is 6 to the negative 4 right now on that example? Sorry, where is 6 to the negative 4 right now? It's on top. If I was forced to, so let me zoom in here. If I was forced to make it a fraction, I could put it over 1 and see very clearly it's on top. So where does it go?
On bottom.
On bottom. As 6 to the positive 4 power. So then, since I have nothing left on top, I need to stick my 1 there for a placeholder. Okay? If I look at negative 8 to the negative 1. Negative 8 to the negative 1 is currently on top. That means it needs to flip down to the bottom as negative 8 to the positive 1. Okay, let's test our knowledge on this third example. Where is 3 to the negative 2? It's on bottom. So where does it go? On top. So if I have a negative exponent that is on bottom, then reciprocal would mean it flips up to the top. Okay? And I want you guys to be careful as well. Because in a lot of these problems, we will have positive exponents and negative exponents mixed together. If you have a coefficient or anything that has a positive exponent, those do not change. Okay? Positive exponents don't change. It's only the one specific piece or couple specific pieces that have negative exponents that move. Okay? So in this problem here, if I put my fraction bar here, 4 stays because it does not have a negative exponent. And then 3 to the negative 2 would flip as 3 to the positive 2. Now, depending on what kind of problem you have, you might want to simplify this into a single number, blah, 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 blah. Okay? But the important part is stuff that does not have a negative exponent stays. Stuff that does have a negative exponent moves. Okay? All right. In big bold letters there, you see that it says a negative. And this is what a lot of you tried to do. A negative exponent does not make your answer negative. Okay? A negative exponent does not make your answer negative. Okay, let's go back up to the problem that the blank that we skipped. Any number except 0 that has a 0 as an exponent. So if you take everything away from that problem, that means anything to the 0 power. So you take all of them away from that problem, what is it always going to be? Yeah, Jacob? 1. It's always going to be 1. If you divide everything out of a problem, you're always left with 1. Okay, so anything to the 0 power always equals 1. Doesn't matter if it's 5 to the 0 power, that's 1. On that second example there, 5 to the negative 2, or sorry, I read it backward. 2 to the negative 5 times 2 to the 5. Well, negative 5 plus 5, I just add my exponents there. I'm left with 2 to the 0 power, which would then just give me 1. Even if it's a decimal, 1.02 to the 0 power, still 1. Even if it's a fraction, all of that to the 0 power is still going to be 1. Okay? Generally, when I see something to the 0 power in a problem, I will literally just mark it out. Get rid of it. Don't worry about it. Bring it out of your mind. Okay? Okay. So I'm going to let you guys practice a little bit here. There are 6 problems there that I want you guys to work on with your partners. Actually, let me start with a few. No, I'll let you go. I'll let you go and see what you can do. Okay? Instead of me trying to kind of help you through each of these problems, I want you guys to struggle a little bit. I think that's good. A little bit of struggle is good. Okay? So make sure you are working in close connection with your partners. Okay? 3 or 4 brains are better than 1. Mrs. Perry and I will be kind of moving around the classroom. I'll try to be peeking over your shoulder to make sure you're not doing anything too terribly awful, and kind of correct mistakes as I see them. Hopefully there won't be very many. Okay? So remember, positive exponent stays put, negative exponent flips. Coefficients, do what you see. Continue to do that. Okay? My only suggestion that I'm going to give you before I let you go, get rid of your negative exponents first. Okay? That's what my one suggestion to you. Get rid of your negative exponents first, and then go back and simplify. Okay? All right, go ahead. All right, guys, we've made some good progress. One of the main reasons that I wanted to just kind of let you struggle for a little bit, not necessarily struggle, but just kind of, struggle through the process on your own, is because there's honestly not really a right or wrong way to do problems that involve negative exponents. Okay, I can kind of show you the way that the progression that seems to be the easiest to me, but there's not really a right or wrong way, especially when you get to some of the problems like C or some of the other problems. Because to be totally honest, you can simplify and then apply your negative exponent and then simplify some more, or you can apply your negative exponent and then simplify. I mean, there are endless possibilities of what you can honestly do, okay? So a problem like A, I would approach and I would say, okay, I'm going to move my negative exponents and get them where they need to be and then simplify if I need to. So you guys just tell me stay or flip, okay? Does 4 stay or flip? 4 stays, right? It's on top, so it stays on top. What about y to the 0? What is y to the 0 going to be? 1. So I know multiplying by 1 doesn't do anything, so I'm just going to mark it out. What about x to the negative 3? Does it stay or flip? Flips. So it flips down to the bottom as x to the positive 3. Can I simplify? Nope, I'm done. All right, B. 1, does it stay or flip? Stays. What about w to the negative 4? Flips up to the top as w to the positive 4. Done. Okay. Don't make that one harder than it had to be. All right. C. We'll come back to C. We'll do C at the end. D. Have you done a problem like this before?
Yeah.
Good. So don't do it any differently. Okay. You do have this extra added lens of a negative exponent now, but you're just going to make more work for yourself if you create a negative exponent and then have to get rid of a negative exponent, because you never, ever, 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 ever have a final answer with a negative exponent in it. Okay? You all hear me say that? You know how to use negative exponents, but you're not allowed to ever answer with them. Okay? So I would do this problem just like I've always done it in the past. I have more r's on bottom, so I have 6 of them on bottom, 4 of them on top. I cancel out as many as I can. I'm left with 2 of them on bottom, and just stick my 1 on top and be done. Don't change the way you've done this problem now that you have negative exponents. You could, but it's going to cause you more work than what we've done in the past, okay? All right, let's look at E. All right, so this is one of these examples where I can't necessarily tell you that there is one way to do it, because I could get rid of the negative exponent and then apply the power of 2 outside. You could apply the power of 2 outside and then get rid of your negative exponent. Generally, I find it easiest to get rid of the negative exponents first, but that's just my personal preference, okay? So inside my parentheses, it's all still to the power of 2, but inside my parentheses, the x squared is a positive exponent, that stays. The y to the negative 3 power is a negative exponent, so it flips as y to the positive 3, and the single z is a positive exponent, so it stays. Okay, so that is my personal preference. I move the negative exponents first. Now I'll go back through and simplify, okay? So I have 2x's on top written out 2 times, so that makes 4x's on top. I have 3 y's on bottom written out 2 times, so that makes 6 y's, y to the 6th. And I also have a single z on bottom written out 2 times, so I have z to the 2nd down on bottom. Make one more quick check. Can I simplify anything else? I can't, so I'm done. Okay? You could have very easily went this route, though, so I'm going to do another route in blue up here. Say I apply my outside exponent first. I have 2 x's written out 2 times, so that's x to the 4th on top. I have y to the negative 3 written out 2 times, so negative 3 times 2 would give me what on top if I went this route? The negative 6, right? Y to the negative 6 power. And then I also have this z on bottom that's written out 2 times, so I have a z squared on bottom. And then say, okay, my x squared stays, so now I'm just going from this block to my final answer, which would give me the same final answer. My x to the 4th would stay on top. My y to the negative 6 would flip down to the bottom, which I did in my final answer. My z squared stays on bottom, which I did in my final answer. So you can see there's a couple different routes that you can go through. I'm not going to tell you any is right or wrong or better or worse. It's just your personal preference. Okay? F. So I, again, choose to move all of my exponents where they need to be, and then I'll go back and simplify later. Okay? So 4 and 12, I know I'll be able to simplify that later, but that's okay. I'll leave it like it is for now. C to the 4th divided by c to the 4th, I'm going to go ahead and get rid of those. They would both stay, but I'm going to just go ahead and get rid of them. Okay? D to the 5th and d to the negative 8. Okay? Well, d to the 5th tells me it stays because it's a positive exponent. D to the negative 8 tells me it flips up to the top because it's a negative exponent. So it flips up as d to the positive 8. My e's, I can see, are just going to trade spots because they're both negative exponents. So e to the negative 1 is going to flip down to the bottom as e to the positive 1. E to the negative 6 on bottom is going to flip up to the top as e to the positive 6. Okay? So you can see that's kind of my first step of simplifying. I just kind of get all of my variables where they need to be. And now I can simplify. What can I divide out of 4 and 12 both? 4. So 4 out of 4 is 1. 4 out of 12 is 3. So I'm left with a 3 on bottom. I have 2 sets of D's on top. So I have 5 on top and 8 on top. How many does that give me on top? 13. So I have D to the 13th on top. And then my E's, I have more on top. So 6 E's on top. Take away the one that's on bottom. I also have a E to the 5th on top. So I have D to the 13th, E to the 5th over 3. Okay? And now let's move back over here to C. Do we have any questions before I move on to C? Okay. C is the only one where I'm going to kind of give you a directive. You can do this multiple ways, but I'm going to tell you the absolute easiest way. Okay? You can do this multiple ways. You may not have done it the same way I'm going to do it, and you may have gotten the right answer, and that's fine. But I'm telling you, if you struggled with this problem at all, this is the easiest way to do it. Okay? What does this exponent out here tell you? What does a negative exponent tell you to do? Don't hurt yourselves. Come on now. We've been doing this all day. What does a negative exponent tell you to do? What? It doesn't tell you to divide. Reciprocate. Okay, make the reciprocal, right? Flip. That's what a negative exponent tells you to do. Flip. So if this negative 2 exponent tells me to flip all of this stuff, that's what I'm going to do first. So I'm going to put the stuff that was on top, 7r, on the bottom. And I'm going to put the stuff that was on bottom, 5s to the negative 3, t to the 0 on top. And now what should my outside exponent be? Now that I've flipped. When we flip, what do we do with the exponent? Make it positive. So it should be a positive 2 exponent now. Y'all see what I did there? All I did was flip the inside fraction and make my outside exponent positive. These are like the hardest types of problems. Okay? So I see that negative exponent on the outside. It tells me to flip my entire fraction and make my exponent positive. Now I can go about my business. Okay? So I am going to or continue to get negative exponents where they go. So inside my fraction, so 5 stays because it's positive exponent. S to the negative, or 7 stays on bottom, that's a positive exponent. S to the negative 3 on top, flips down to the bottom as S to the positive 3. T to the 0, I'm going to just mark that out because I don't care about it. It's going to be 1. Multiplying by 1 doesn't change anything. And don't forget about the R on bottom. The R on bottom is a positive exponent, so that stays as well. And then all of that is to the second power. Now, lastly, I will apply that outside second power. So 5 squared would be 25. 7 squared on bottom would be 49. S, so I have 3 S's written out 2 times, so 3 times 2 is 6, so I have S to the 6th. And then I also have a single R written out twice, so then I have R squared. Check one more time, make sure you can or cannot simplify. Can I simplify 25 over 49? Really, the only thing that goes into 25 is 5. And that doesn't go into 49, so I'm done. Okay? So that's kind of the extreme problem. If you got all of the rest of them and you were kind of sort of confused how I was doing that problem, you're pretty well off right now. Okay? That was kind of the extreme problem. Okay. All right.